Python lists, are they empty? 3 techniques you need to know.
Welcome to another video on smart architectural programming. My name is Mohammed and coding alongside me
Is George, and today we'll be going over the topic, pretty much determining if a Python list is empty or not. Thank you.
as George mentioned the topic, many of you would have noticed or noticed and thought about it, that this topic seems way too basic. Everybody knows how to do that. While a lot of you people might really know how to do that, but every month, thousands of you people search and look for this answer on the internet, on YouTube, on any platform they can find this information on. And hence, it becomes important that we address this issue within our channel, because I mean, if there's an issue that a lot of programmers at the basic level, more than likely, or even at the higher levels, need a refresher on exactly on how to do this, it is imperative that we impart this knowledge. Also, while there are many different ways you can identify if a list is empty or not, there are certain specific ways which are more powerful, more effective, or more flexible that you can use in different scenarios. So we'll go over 3 different ways on how you can identify if a Python list is empty or not. And then we'll tell you which method is the best way, which gives the most flexibility in usage and application. So without further ado, let's start. Our first method is using the len function, a len function to check the length of a list. This is a built-in function in Python that a lot of people may already be familiar with. It's used to check the length of different data types within Python. In our case, in specific, we can test how many values are in a list and enumerate them as the length of the list easily with this len built-in function of Python. So simply we use an if-else statement to check if the length is 0. Because if the length of the list is 0, the list is empty. So if length of my list equals to 0, we print the list is empty, else we print the list is not empty. We run this script and simply the list is empty because the list that we declared right on line 1 was an empty list. And when the length function was called on this list on line 3, it equated to the 0 value. Now, with the first method out of the way, we'll move to the second method, and probably the most Pythonic and flexible method that among these 3 methods, which is using implicit Boolean evaluation to check whether a list is empty or not. Now, this might be slightly tricky to get your head around, but if you understand this, you'll probably be able to learn a very powerful trick and a very powerful concept in Python. So remember, empty lists are considered a false value in Python when used in a Boolean context. Meaning, when Python tries to understand lists as a Boolean, it is either true or false. A true list is when the list has values in it. But if there are no values in a list, Python considers that false in a Boolean context. We can see in my code, if you can look at my code here, we can see just like the previous script, we declared in line 1 an empty list, and we're using an if-else statement here as well. But what you'll notice here, we use the syntax in line 3, which is if not my list. So we're using if-else statements to check if a list is true or false here. So if we use if my list, we're asking Python to check if the list is true. And when would the list be true? When there are values within the list. So when there are values within the list is true. And if we wrote if my list, which means the if statement is checking if the list is true, which means it has values. So when we add the not keyword between if and list, it means check if the list is false, which means the list must be empty or null. So if that is the case, print the list is empty. If not, print the list is not empty. If we run this code, you'll notice it works perfectly. The list is empty. But supposedly I add a value within the list and run this code again. the list is not empty. So it means that the code is functioning as it should be, and it works fine. This method might be a little bit, you know, not simple as the other two methods might be, but it is probably the best way to solve this problem in Python basically. As it grants us a lot more flexibility in dealing with different data types, not just lists. Now, coming to the last method in to identify if a list is empty or not, we use the comparison method. So we simply compare the list with an empty list in an if else statement. That's it. That's all we're going to do here. If you look at our code here, we again declare the list as an empty list. Then we check if the list equals to an empty list. We're using if else statements like the other two files, but we're just doing a comparison operation, checking if the list is equal to an empty list. If it is, print the list is empty. If it is not, the list is not empty. We run this code here. The list is empty because the list is empty here. We add a value. We run this again. The answer comes in the list is not empty because the list is not empty at that point, which means the code is functioning as it should. As we are wrapping this video up, because again, this video didn't have much to, much information to provide, but it did focus on a specific issue that a lot of people are still struggling with or trying to get a refresher on. So while all three methods here were valid, the second method using implicit Boolean evaluation is probably considered the most Pythonic, most best way to solve this problem. And that is why I often recommend this method for its simplicity and readability. Additionally, again, I mentioned flexibility, right? The thing is you need to understand chunks of code because there are thousands of different ways, or not, if not thousands, there are tens of different ways to do the same thing in different ways in programming, right? And what at that point, what you need to understand is what differentiates a good programmer from the rest is his ability to leverage mechanisms that could be used at different scenarios or different data types or different things with the same programming logic. So the second method not only works for lists, but it also works for any iterable types like strings, tuples, so on and so forth. So it provides greater flexibility. So if you learn that method, you can not only use that on lists, but you could also use that on strings, you could use that on tuples, and other iterable data types that might be available. So with that, I'm going to wrap this video up. George, before we wrap this video, do you want to add anything at the end?
No, I think you covered everything. Thanks, guys.